Okay, so here we are on our third week of tips and tricks. And we've got our expert panel here who will share some tricks, and we may have some good Q&A coming from one of our guests here. So that's great. Stay tuned.
In our first tip, we are going to create a table, a data science table. So to start with, we need to import the data science module and NumPy. And once we've done that, we can create an array. Now in this case, our goal is to create a table which shows us the snowfall as a function of a month. The months will be designated by numbers. So we will use an array developed by using NumPy arrange. This will give us the numbers 1 through 12. We store that in the month array. Then the new thing is we can create a data science table. We start with a blank table, and then using the with columns, we can label a new column as month and place in that the array that we had created in order that we will have data within the table, which starts out as empty, and then we put the columns in with columns. We will use the assignment operator equal to store this in the variable snow. Here, just for convenience, we print it out, so indeed this is the array that we had hoped for with the month numbers, and then we can show what the table is, and you can see the label, the string label at the top. Okay, in our first tip today, we are going to create a data table here, and we're going to do so by creating an array, and that array is created by using NumPy arrange. Now here we're goal is to create a table looking at the snowfall values for each of the months. We'll create a numbered array from 1 to 12, and then we'll use the with columns and the label month to put this array in there. So this works quite well, and it's very useful.
So for my presentation today, I would be doing a little bit of like non-P, kind of like creating like arrays of like there's different kinds of arrays. You can like have like a NP dot array, and then you can also have you can create like a list. You can also create like sets, tuples, and things of that nature. So I'm gonna like show you how like you can like use each one and how to like differentiate them. Because I feel like as you go along in the semester, a lot of students can like, they want to use a list, but they're using like syntax of a tuple to represent a list, and then they have run into issues. So just kind of like giving like a more visual representation of each. And also very important, like every time you um are dealing with libraries, whether you're working on it now or you like close your laptop and you come back, it's very always very important to like go back and run it again before you like continue, because sometimes you will have issues later on and it's just as a result of like you not running the libraries in advance because you've used it before, so you thought like it carried over a couple hours. So first I ran the what do you call it, the data that we imported, which is the numpy as np, and from data science like importing it all because we don't know what we're going to be using. And then I created a variable called ages, and to like to put data into it, I did np.array since I'm working with the numpy data library. And then I inserted like variables like 22, 23, and row and 24. Then I created another one for names, and then I have like one for strings to represent like the names of that are going to be in the stored there. And then I created a table, and creating a table is pretty easy actually. So you create like a variable, and then you set it to equals table, and then you always have to use the with underscore column when you're referencing like a table, and you have to like make sure like when whatever you put into like the string matches with the actual table when you're calling it later. So you have to like pay attention to that as you're going when you're creating your tables. And you give it a name to represent names, age to represent age, and then when you do table dot show and you run that, it displays like the data that you just created for the table. So it's mapping the names to the table name and then the age to the table age. And then you get to show that. And then this is creating like a list. Like I said, this is like an array. And then when you create a list, you just have just uh parenthesis, I mean bracket, just open bracket. You don't need the np.array because it's just a list. And then you have the same format. And then when you run it once again, it shows you the same result as well. It's just syntax wise when you're creating it in the first go. And then this is another example using tuples. Tuples uses parentheses, and they also don't need the np.array because they are tuples. And when you run the same code, you also get like the names and the age. And obviously you can like keep adding on to like the table as you go and like, import like adding more variable as you go. It doesn't have to be the same thing. If you want to also change the table later on, there's also ways to do that as well. And then there's sets. And for sets, you use like a curly braces to represent the data inside of the sets. And when you call them, you have to like convert them to like lists to use them. And then that way it's easier for you to also, once again, like use that in a table format to get the names, set the names for the columns and like put data into each column as a whole. And you run that, it gives you the same result as well. And then another way you can just create tables if you don't want to go by like just having like to first create a variable and assign values is you can just create like the variable table, have like table open and close parentheses dot with column. You create the name of the variable of the column that you want, and you just separate it with a comment and you put the data that you want. You also do that with the age and you put that and then you close it. And then with that, when you say age underscore, and you want to extract the age, you just put it in the parentheses in the column using table.column to get the age that you just put into the table. And when you run it, you can get just how it is in the table. And then same with like the data. In here, you want to convert like NumPy arrays for using the table. And for arrays, how they work is they work by indexing. They start with 0 being the first item in the array all the way to whatever number that you have in the array. So since we have 3 things in the array, we're gonna access them by like 0 for the first one being Anna 22 in New York, and the second one being for row 1, Nas 30 Los Angeles, and for the third one being row 2, you're gonna access the Charlie 22 Chicago data. And you just have to run this since you're gonna be using the data from that. And then also you create the table and you access those values. And then when you do people.show, since that's the name, I mean people table, that's what you created as the variable to store what you want to extract from the table. And then you run it, it will show you this and create like an actual table for that. And then this is just another way for extracting specific things and like printing it out to look more presentable here. And also you can, but yeah, that's pretty much it. And also for later use, like as you go in the semester, when you also want to like replace something, you just create like a variable and you access what part of the table, and then you can just change it in the print statement. Yep, and that's it for my presentation.
Wow, quite a tour de force between the two of you, really showing the ins and outs of how you work with small manageable data sets so you can kind of track where the numbers are going, the ages, the names, whatever they might be. And if you encounter things like a tuple, whatever, it's manageable. You can work with those in a very similar way to lists or arrays.
So, yeah, so that's super. I think, between both of your presentations, it's great. We see kind of a wide range of how we can create those relatively simple tables. Preview of coming events is when we begin to load the tables with, for instance, data that's outside comma-separated value tables. So, exactly. Any other, particular comments at this point or questions?
I just have one question about kind of the formatting. So like when I go into lab 3 and I go to run that first real set, I get hit with a syntax error about the indentation. And so I wasn't totally sure, like if I'm just missing a piece of the code that's supposed to go in there, that'll kind of get rid of that message. Or like if I just kind of imported it wrong, I don't know. So yeah.
It has more to do with like, so in Python is like specific to like how you write your code. So like in some languages, you can just write it in whatever order, it doesn't really matter. But Python, especially when you're dealing with like loop statement, like if you're gonna write like a if statement, after you write your if statement and you put the column and you go to the next line, you have to shift, like you have to click a tab like to go next, space, and then continue. So when you're getting like an indentation error, just put like an extra space in front of like the line before. It would tell you in the error message like where the indentation problem is coming from. You just put a space to it and you just shift it and run it again, it should work. It's not about like an import, it's just more of like spacing. Like it just wants it to look a specific way. Yeah.
Exactly. Yeah, I think, let me show briefly here, and we can see if it's the same kind of issue that you're encountering. So this is some stuff from class 5, but the point is, more we'll create a few cells here just to look at. So if you, even in a simple kind of thing, so if we do that, that's fine. That's fine. But the thing is, if then we have we don't want to actually, we want to call it like my list equals dog, comma, cat, something like that. So all these are on the same indentation level. If I, just a little strange, if we start indenting something, then that indicates that we are in the midst of a loop, which is kind of what Fahita was saying. So it will give you an error. Okay. I'm not regenerating the error. I was hoping I would be able to regenerate the error that, yeah, okay, here. That might, I don't know if that's what you encountered. But
Mine
yeah,
was kind of saying syntax error, and then the arrow from the actual error was going towards that first quotation mark. So that's why I was a little confused. I was like, do I have to change the quotations from a double to a single, or am I missing a space?
okay. Okay, so a little clue might be if the syntax error was coming at the beginning, like let's say by mistake you did something like that, okay? Here, even if it's not indented, it depends what you're trying to do with it. This is just a string here, and it's displaying the string, okay? You sometimes people will put quotes around something that they're trying to get inside the quotes to understand, like, see here, it only says my list.
If I remove the quotes, then we actually see what's in my list. Okay. So you have to be careful when you use quotes. Okay. Because quote is what's called a literal, meaning when you put a quote there, you literally mean the characters in that quote. Okay. And it may be a little confusing because in lab 2, we did do an exercise with something that was in quotes, and we went inside it and evaluated that thing. So for instance, if we evaluate something that's like quote 3 times 6 or something like that, we get 18. But if we just print that, this is the more normal, we get 3 times 6. Okay. So that evaluate statement is to demonstrate a couple of things with find and replace. I mean, with the replace, and it is a valid command, but it isn't typical that you would put something you're going to operate on in quotes. So I'm not sure if I touched on, really the error that you had encountered, because I'm getting indentation errors as opposed to syntax errors. Okay. You might get if you put a colon here, see the colon at the end, you don't want to put a colon at the end, because this goes back to what Vahida was bringing up. That is part of an expression. So we haven't gotten there yet, but if 5 is greater than 3, then it automatically indents. So that's where the indentation comes in. Then this is an obvious outcome. 5 is 3. Okay, like that. More typically, you would have variables here as opposed to the actual numbers. Okay, so. But you see, there needs to be something indented after you have the colon. So we haven't really covered this if structure yet. It's coming. But that is what you're implying when you start putting colons at the end of your line. So, okay. Other questions out there? Yeah. So I think, kind of the goal here is getting very familiar with working with these different data structures, particularly sequences, and then bringing them together into format, particularly the tables, but pandas is also a related format, and being able to manipulate them. Because realizing inside the table, for instance, we can extract an array from the column of the table. How do we do so? With the dot column command. So, yeah. Great.
So I'm just going to be presenting some examples of working with lists, arrays, and building tables. So I'll just start off with an introduction. What's the use of tables and why do we use them in Python? So you can think of tables as kind of like an Excel sheet. Like it's a place to store large amounts of data. They help organize data in rows and columns and make things easier to see patterns and analyze information. We see tables in everyday life. You've probably seen tables in like news reports, on websites, anywhere really. So now lists are really important for building tables. You need a list to store a lot of the data that you present on the table. And in Python, you can imagine a list as kind of like a shopping list. It stores all the data in a single line, kind of. In Python, lists can hold different types of items like numbers, words, or a mix of them. An example of that would be something like a list that stores the number 1, and then the string or word apple, and then even a double like the number 3.5. Yeah, so here on the top of my notebook, you can see I imported something called NumPy. Sorry. NumPy is short for numerical Python. It's a popular Python library. It's used for numerical computations, and it introduces a data structure called arrays into Python. This is kind of like an advanced version of a list. It's more specifically designed for numbers and mathematical operations. So yeah, NumPy arrays are faster than a regular array or list and more efficient for calculating regular Python lists, especially with dealing with larger amounts of data. So, so here I import NumPy as NP, and I name my array right here, my array, NumPy.array, and then in these parentheses, I add the data that I want to display right here. And I use this print statement to organize my array neatly right here. And I've already ran it, I'm sorry, so it already shows you the output, but yeah, I'll run it again, and it shows you, it outputs the array and all the numbers neatly. Another example is using NumPy to create 2D arrays. 2D arrays are basically like a table. Here you see I add the data, but I'm able to add 2 plots of data basically in between these brackets and these brackets right here. And I use this comma to separate these 2 clumps of data. And then I also create a nice little print statement to neatly display the information. Let me see, I think I used it again. I might not have it on here. All right, and then pandas. Pandas is a Python tool that helps you work with data similar to NumPy, and it's used to organize data in tables. And we're going to be using tables a lot in the coming lab, so you'll probably be using this a lot. Something useful about pandas is you can sort, filter, and calculate data just like you would in an Excel sheet, but you can use it with bigger amounts of data. So here I import pandas up at the top, and I import it as PD, and I use pandas down here when creating a table. So here is where I store the data for my table, and in between these curly brackets here, I have the first part of the table, or the first column, and I want the first column to be name. You see it down here, and these are the names that I want to be stored, that I want stored in these columns. And then I want the other column to have age, store the ages of all the names, and in between these just regular brackets, I store the data that I want to display in the table. So then I create a variable to store the data frame, or basically this whole thing for the table, and then I create a print statement just to display this neatly. And yeah, I can run it here for you, and yeah, this is what it displays. And it's not limited to just 2 sets of data. I can do it for more, like I can do address. And I'll run it again here, and you'll see that these will display next to the corresponding names and pages right here. So here is an example of me using NP Array to create a 2D list. So here I'm storing two different lists in one variable. And then I create a nice print statement just to display it clearly. And yeah, I'll run it for you. You might already see it. And you also, the usefulness of an array is that you can manipulate a lot of the data very easily. It's easy to manipulate large sums of data using mathematical like concepts. So here you see I'm printing the original array. This is the array that I created up here. And yeah, so I want to add 10 to every piece of data in this array, and you can simply do that by naming a variable to store the array, calling on your array, and then adding 10 to it. And then here I write a nice print statement, and then you see down here adds 10 to everything, and then here's an example for multiplying everything in an array, and I multiply everything by 2. So yeah, that's basically what I have to present today. I hope it was helpful.
Oh, that was super. Yeah, that's great. So lists, arrays, and pandas tables. So that's super. Now with the pandas table, it's great to see it. It differs ever so slightly from our tables, which is fine. But it's good stuff to learn. And a lot of the concepts in terms of putting a list into to fill up that type of data frame table, same idea. So that's super. Yeah.